Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night. I'm Wayne Zool, and I want to welcome you to what I believe is a fun, interesting, and informative episode. A couple of years ago, during the height of the pandemic, a good friend, Tony Costanzo, owner of the Astronomy Shop, began holding weekly get-togethers over Zoom to discuss various topics about telescopes. The meetings still take place and are a lot of fun. One of the people who attends these meetings is my guest on this episode. Michael Corvese is an amateur astronomer based out of Rhode Island. He's retired from Fisher Scientific, and as you'll learn, he's been interested in astronomy for a very long time. Michael enjoys planetary and lunar observing quite a bit, and that interest led him to making a presentation to his local astronomy club and then to our Zoom group. I was so impressed with his presentation that I knew I had to have him on the podcast. So I hope that you enjoy this as much as I did. So welcome. I'm Wayne Zool. This is the Astro Guy podcast, and today we are joined by Michael Corvese, and we're gonna do some talking about the moon and some other things related to the moon. But I want to just go through a few different questions. Michael, when did you first get interested in astronomy?
Well, Wayne, first of all, thank you for inviting me to the podcast. I really appreciate being here. Began astronomy when I was a young boy, was the time of the Apollo program. So everything was space oriented. So there was a lot of interest. At the time, the moon landing, I was about 6 years old. So through that time, very interested in space. And then I had the good fortune of having a few good science teachers in fifth and sixth grade that really opened my eyes to astronomy and what was out there in the universe. And then around that time too, my father had bought me a small telescope. I think it was a 60 millimeter Tasco. And unfortunately, I really didn't know how to use it, and my parents weren't skilled in using it. So, I looked at the moon, but that was about it, and really didn't get a lot of use out of that telescope. So my interest had lain dormant for a number of years, and when I was in college. I began to become more interested again, and not being able to afford a telescope at that time, I had a pair of binoculars, a small planisphere, and I bought a Peterson Field Guide to the Stars and Planets, and that's how I learned the night sky. I went out there with my binoculars, and I learned the constellations and some deep sky objects that you could find with the binoculars and looking at the planets, and then from there it just blossomed as I matured as an adult.
I know for me the space program certainly was a factor. I was very young for Apollo, but it was certainly a driving force. And I've mentioned on here I grew up just a few blocks away from a community college that has a pretty amazing observatory, even though it's in suburban New Jersey, about 12 miles from New York City. But there's some great scopes there and great people, and I was able to learn a lot about the hobby growing up, and it really shaped my life. So on the as far as observing goes, and I know that you're a pretty active observer, what's your favorite type of thing to observe, and why?
Hmm. Well, I have to say it's kind of like my personal life. I have many interests and they go all over the place, right? So, right now I'm starting to get into a double star mode, right? But I've spent a lot of time, looking at the planets, looking at deep sky objects. Out of deep sky objects, I would have to say star clusters are probably my favorite because it seems you can look at them and it doesn't matter how many times you look at them, you can see different things. You know, or you notice different things. You know, it doesn't change, of course, but you notice different star colors or different patterns within those star clusters, and it's just very, you know, amazing to me, you know, to look at those. And of course, I love looking at the planets and the moon as well. So hard to say what would be a favorite.
And I'm with you on that as well. Open clusters are my absolute favorite thing to observe visually. I think they have so much character, and I think a lot of people overlook them. A lot of times they get lost. Especially if they're in the Milky Way, in that band of the Milky Way where there's so many stars, they get lost. But
Right.
there's so many. I mean, you look at something like double cluster, which I never get tired of. And there's a really cool open cluster right near the double cluster. It's about 2 degrees away called Stock 2. And it's huge. It's about 2 degrees long. It looks like a strong man, like a stick figure of a strong man, and it's very distinct. And a long time ago, probably about 35 years ago, a buddy of mine showed it to me, and I was like, "Oh my God, that's really cool!" And it's bright, it's big, it's easy to see. Uh, but I go back to open clusters visually, and there's so many that are so. I mean, M46 has got a planetary nebula in it. So uh, eh, I know a lot of people think globulars are really cool. I like them, but I go more for the opens. I think they have a lot more character.
Okay, I agree. I agree with you because you notice something different every time you look at them.
Exactly, exactly. From an astrophotography standpoint, which the globulars are certainly more impressive. And I one of my first really long exposures I did was, and it was only an hour, but it was on the Beehive cluster, and I was really disappointed because it didn't look all that different than it looks in the eyepiece, with a wide field image. So,
Yeah, that
uh,
makes sense.
but that one, that's such a big cluster, and but anyway, we're getting off topic, but uh, other science interests besides astronomy, do you have any?
Yeah, I see. I've always been science oriented. It goes back to those two teachers I had in fifth and sixth grade. They were great science teachers, and it set my career on the path to the sciences. So my background is my undergrad degree is in chemistry, and then I worked for a very popular scientific company, Thermo Fisher Scientific, who manufactures analytical instruments. So I did that for my career. I also worked for an environmental laboratory for a number of times. So my whole life has kind of been in the sciences. But for leisure, I actually enjoy cosmology and quantum physics. I know people think that's a nutty, right? You're for fun, but I enjoy reading, like, Stephen Hawking, Brian Greene, Richard Feynman. I like reading those books, and because it's just for me, it's so unfathomable. Like you're trying to wrap your head around the concepts of the universe and some of these concepts in quantum physics. I just find it very intriguing and exciting, and that's probably my biggest interest in science outside of astronomy.
That's cool. There's some really great podcasts out there of people involved with cosmology. Neil deGrasse Tyson has a really good one, and he covers all kinds of topics. It's not just uh, physics and cosmology. He does sports themed episodes. He has a comedian who's his sidekick, and Brian Cox just revived a podcast that he was doing. It was actually a radio show in England called The Infinite Monkey Cage, I think, and it's really good. It's really, really good. He gets great guests. It's in front of a live audience. It's very funny, but really very interesting. I know we kind of asked about your favorite type of object. Do you have a specific object that's your favorite?
I mean, I like looking at M13 under high power in a clear sky. On those nights, I can almost see it in like 3D. When I can really ramp up the power when the seeing is exceptionally good, I can almost see like around it, and it's kind of just amazing. And so that's probably, if I had to pick one favorite, that would probably be That would probably be it, but it has to be under those pristine, perfect conditions for it to really kind of pop out.
Have you seen the propeller that some people see in M13?
I never have. No, I have. I actually, to be honest, I wasn't even aware of it.
There's some people say they can see a three-bladed propeller of stars, and I've only seen it in images, but I've never seen it visually. And I mean, I've observed it with everything from a 24-inch scope to a 2-inch scope.
Right.
I've never been able to see it visually, but in
Oh.
photographs I have seen it, and I've seen sketches that people have done where you can see it. But that's
Oh.
M13 is a really cool one, and actually, um, when I go to dark skies with at least an 8-inch scope, the test for the sky is can you spot the little galaxy that's off to the side of it, and there's a tiny little galaxy. It's like I don't know 14th magnitude or something, and
Mhm.
I've seen it once from Vermont with an 8-inch scope. So it's a tough one. But speaking of telescopes, do you have a favorite scope or a favorite piece of gear that you use?
Yeah, I kind of go back and forth between I've got a C11, an SCT, and I've got a small 90 millimeter Questar. And depending on the conditions, if it's going to be a quick night of observing because there are predicted clouds or fog or something, then I'll run out there with the Questar. Or if I'm doing some lunar observing, I'll use the Questar. If I'm going to have a really good night and I want to spend a considerable amount of time out there, and the conditions are predicted to be right, then I'll take the time to set up the C11 because I don't have an observatory, so I've got to lug it up out of the basement, set it all up, do all the alignments, and get the thing running. So I'll usually use those two. I've got a couple of other smaller scopes that I don't use as much, but those two are my standbys.
The Questar, I'm jealous of that. That's a really amazing telescope, and optically with that quartz mirror, and they're really just absolutely wonderful scopes to use. And the Celestron, I mean the C11's big. I have a C8, and I love it, but they have their quirks.
Mhm.
Collimation can be tricky,
Mhm.
and you have the mirror flopping around. So there's issues with them, but I've been able to see and image some amazing things with the C8, so I can get that. And having that extra aperture, it's all about aperture when
Right.
once you get into the hobby. So speaking of that, like starting off small and getting bigger. Do you have plans for anything bigger? Any future projects or things that you're working on?
Now, unless I'm hoping to, potentially build an observatory, small roll off. I'd like to put, and I've got some space in the back where I could actually put it, and then I might go for something bigger at that point, because again, as you mentioned, you get that aperture fever, right? I've got the 11. Maybe I want a 16 or a 20, right? To kind of see how that performs. But something of that size, I'd want to be able to mount it, permanently in something, and not because those certainly, as you get those larger sizes, they aren't portable anymore. The OTA and the fork mount is about 75 pounds.
Wow.
And it's, I got to, lug that up out of the basement, and I'm not getting any younger, right? So, right.
That's why I keep them. I keep well, fortunately, mine's in my garage, and I roll it out to my driveway. But I have this. I don't know if you can see this, but I have these casters here,
Yes.
and I bought a set of four. They were like $20 on Amazon. So I put one under each leg. I keep a spare in the house for, if we got a package in that's heavy and I want to move it. Uh, I keep it
Nice.
handy on my desk here. But uh, having that convenience of rolling it out is great. One of these days, probably in the next 3 to 5 years, hopefully, we'll move. And one of the things one of my needs is a backyard with a wide open space and a good horizon.
Yeah.
especially a good southern horizon. So, but that's the future. So, one of the things when we're recording this, it's August 31st, and a couple of days ago, Artemis 1 was supposed to launch. They had to scrub the launch because of I think it was a sensor problem. They think it was a sensor that was malfunctioning. Um, and they're going to try the launch again Saturday, September 3rd. I think around 2 something in the afternoon, 2:17, I think. But for me, I found Artemis to be extremely exciting. Uh, like I said, I was very young when Apollo launched. I remember it. I actually remember watching. I don't know if it was Apollo 11. I think it was probably one of the later ones, but I remember watching launches, uh, and it was very exciting for me. And now with Artemis, the fact that they're able to do so much more, and they're using, yeah, it's almost like they're cobbling the thing together. Although I know they're not, uh, but it's great because it's bringing everyone's attention to it. It's a very exciting thing. A lot of people are excited about it. And the moon, it's right here, and it's a really, it's there's so much that we can learn still, and there's resources that we can use, to help make things better here on Earth. So I think let's transition to the moon, and I'm going to let you take things over.
Okay. My interest in the moon is fairly recent. I like many other amateur astronomers, the moon was always a hindrance, right? Because it didn't allow you to see those those dim objects out in the sky, and so I would not even take my scope out when when the moon was predicted, when the moon was going to be out during that cycle. It was just like, okay, no astronomy during this this week or so. But over the last year, I became more interested in the moon and spent a little more time looking at it. Bought some charts and maps, and began to look at features. And then through my local astronomy club, of which we are a member of the Astronomical League, so we are entitled participating in their observing programs. Back in January of this year, I started a lunar observing program with my local club, which is the Skyscrapers here in Rhode Island. And 15 people. The astronomical league allows you to complete the program. You have to find 100 features on the moon, which different things, craters and rills, and as I begun to go into this, I'm naturally a curious person. I'm like, okay, what a rill is, what's a rill, and so I would go look that up and figure that out. And so I ended up learning quite a bit about the moon and becoming quite interested in it over this past year. And I happily can report that I just finished the Astronomical League program. Got through the 100.
Congratulations.
Yeah, it was not, it was difficult, but in order to get the best view of some of the objects, you had to wait for certain parts of the cycle, of the lunar cycle, to be able to see them. So you'd have to plan ahead and hoping that the weather would cooperate. Say, okay, the moon's at this phase, I can get a good view of that. You go through the list, but it took me 7 months to get through it. I started the program in January, which, lesson learned, not a good time to start an observing program in the middle of winter in New England. Right? So, I'll do that differently next time. But in doing that, I also, Wayne, I wanted to share with you a recent presentation that I made to Skyscrapers a couple of months ago. As I became more interested, my question was, where did the moon come from? Where did that come from? And if you would, I'd like to share that with your audience. So the presentation was titled, where did the moon come from? This photo really has nothing to do with the presentation, but I kind of liked it. This came from what is labeled as the first science fiction film ever made in 1902 in France, and it was called A Trip to the Moon. Look it up on YouTube. It's about a 13-minute film. And it's pretty interesting because it was the early days of film. They hadn't really gotten the techniques down, and it's basically a filmed vaudeville show. With the vaudeville sets and costumes, and it is an interesting 13 minutes to watch it. So when we look at the moon and the mythology, the moon as it changes through its cycle became just that for ancient civilizations, a symbol of time and change and the repetitive cycles. Most cultures, the moon was associated with bad things, with death or places where the dead would go. Others they were a little more positive. The Romans, we get the word lunar from the Latin word luna, which comes from the moon goddess of ancient Rome. And the Chinese and most of Asia today have a very popular moon festival in September every year. And it's the second most important holiday after the Chinese New Year. That one is looked at in a very positive light. Going back about 2,500 years ago, a man named Anaxagoras, who was a pre-Socratic Greek philosopher, so this is going back about 500 BC, had some interesting observations about the moon. The first to realize the moon was not lit on its own, and that it was reflected light from the sun. He was also the first to explain the moon phases and eclipses by the positions of the Earth and the moon and the sun. He was also the first to hypothesize on the fission theory that the moon actually, became was taken from part of the Earth and was placed into orbit. Unfortunately, his scientific mind got him into a little bit of trouble. He was eventually exiled to Turkey because he would not acknowledge that the sun and the moon were deities. He saw them as they were, as these planets. He actually thought the sun, was a molten ball of burning metal, which isn't that far off from what we know that it is today. And this is going back 2,500 years ago. So an interesting character, this Anaxagoras. But moving up into more modern times, one theory that was put forward was called the Accretion theory, or sometimes called the condensation theory. It was first developed in 1735, and then expanded later by Pierre Simon Laplace in 1796. So the theory is that in the solar system, in the accretion disk, as the planets were forming, that the moon and the Earth formed together. During this. So, his hypothesis was that, the solar system was formed this way, which is essentially correct in what we know today. But his theory fell out of favor in the 19th and the 20th centuries. People were thinking about other ways and other actions. Laplace, for any science and engineers out there, Laplace was also a famous mathematician and was famous for developing what was called the Laplace transform, which is a tool used for solving differential equations. And I put one down there in the bottom corner of the slide, just in case you had any unsolved differential equation you need to take care of. But again, moving ahead a little further into the 19th century, there was the fission theory, and this goes back to what Anaxagoras said about a piece of the Earth being cast off and then becoming in orbit around the Earth. George Darwin, the son of the famous biologist Charles Darwin, in the late 1800s, put this forward. His theory was that when the Earth was in mostly molten state, it was spinning very fast, and as it spun, it caused a bulge. Okay, as it was spinning very fast, and then that bulge actually had enough force to pull away. and then to be formed into the moon. And that was his theory, the fission theory. Moving ahead a few more years, there was also the capture theory, which was that the moon was originally from a different part of the solar system and was captured by the Earth's gravity and was placed into orbit that way. The man who put that theory forward was a man by the name of Thomas Jefferson Jackson C. And a very colorful character, had the dubious distinction of being wrong in just about every theory he ever put forward in physics and astronomy. A bright student, he graduated from the University of Missouri with distinction, top of his class in every subject, and this was in the late 1800s. Went on to the University of Berlin to get a PhD. Came back to America with that European PhD, which was a big deal back then. That a European one was much better than an American, right? And he came back and had such promise. Unfortunately, due to his personality, he ended up getting fired from a job at Lowell Observatory. He got fired from the U.S. Naval Observatory, and was just a very abrasive character. They eventually placed him out in some obscure shipyard to be head of the timekeeping station there. But during that time, he continued to publish, very vitriolic papers, against people who had shredded some of his theory. He even went so far as to, vicious attacks against Albert Einstein and the theory of relativity. But by the time that came around, he was mostly being ignored, right, by the scientific community. But unfortunately, just a case of wasted talent because of his arrogance and his carelessness. His science was not very credible. So, we've got these three theories. Which one is correct, and there are pros and cons for both. Some of the cons we could look at, say, for binary accretion. Wouldn't you think the Earth and the Moon would be more similar, right, if they had kind of grown up together, right, in this accretion disk? For fission theory, later on in the early 20th century, with advances in fluid dynamics, it was determined that the Earth could not spin fast enough to be able to, throw off a sizable chunk of mass in that way. And in capture theory, again, later in the 20th century, it was determined that, again, a body passing the Earth that large, the Earth's gravity wouldn't be strong enough to overcome the velocity, and so that was thought of as maybe not a viable way. So, that debate continued all the way up through the 1960s. There were advocates for each one of those three theories. Neither one was eliminated. And then the program came along, and the mission of Apollo tried to determine the origins of the moon and which of these three theories were correct. They were very specific about where they wanted to collect samples because they wanted to be in geologically different areas. To try to determine the origins of the moon. So, the early results came in, and it yielded results both for and against each of these theories. And it wasn't until after a few more years of analysis that evidence started to pile up for the giant impactor hypothesis. Okay? And this was first put forward in 1946 as a challenge to the fission theory, that a large body, collided with the Earth, and how the moon formed. This was given a little attention until 1974, when Hartman and Davis again began looking at all of the data. So this is several years after the first moon rocks had come back to Earth and were being analyzed. But they began to see, patterns in the data. And by 1984, this was the accepted hypothesis for moon formation. So the thought is a body about the size of Mars crashed into the Earth, and the energy of that explosion created a ring of debris around the Earth, and then that ring coalesced into what is now the moon. And so some of the evidence for that was, they've since learned that the moon was once molten to a very substantial depth, which meant that that would require more energy than could have been gotten through simple accretion. The moon is also depleted of volatile compounds and abundant in refractory elements compared to Earth. Now, what that means is that that's evidence of a massive energetic explosion, right? All the volatiles get burned off. The only things that stay are the refractory metals that can stand the heat, if you will, and those things, form together. Also, stable isotope ratios of oxygen and titanium are nearly identical to those on Earth, which leads to a thought of commonality. But then there are other types of elements that are very different. So there's almost this thing that, well, pieces of it, the Earth are there, but there's also pieces of something else. And so again, this was another point in favor of the giant impactor theory. In some of the other evidence, the moon being, less dense than the Earth, being that, when the collision took place, the larger core of the other impactor would have been mostly absorbed into the Earth, and that's why the moon has a significantly smaller iron core. There's also anomalously high angular momentum between the Earth and the Earth and the moon. And what that means is the angular is the spin of the Earth. If we look at the Earth within the solar system, it spins faster than every other planet. And so that energy to create that spin had to come from somewhere. And they think that this giant impactor came in on kind of a glancing blow and kind of set the Earth into that spin. It's also thought that that type of a collision would likely have put the Earth on that 23-degree tilt in its axis, giving us our seasons that happened during that collision. And also the Earth's spin and the moon's orbit have a very similar orientation. So these are all favor, of the giant impactor theory. Others have continued to do research. Nobody has discredited the giant impactor theory, but there have been modifications and alternatives. One recently that has been gaining a little bit of traction is that it wasn't one giant impactor, but several very large objects that kind of came in at the same time and hit the Earth. And there's some evidence, to correlate that, but that's that kind of takes us to the end. But that's kind of a quick rundown of how we think the moon has formed. Again, the giant impactor is still a theory, but right now it's the one that's most in favor and the most evidence. And so we've kind of pushed the others, the fission theory, the capture theory, and the binary accretion theory, kind of to the side and left the giant impactor theory there.
You had said something about the spin of the Earth's rotation. We know Mercury its day is longer than its year, and Mars, or Venus has a pretty long day. Its day is almost as long as its year.
Right.
But Mars has a very similar rotation to the Earth, and Jupiter and Saturn. I think all the gas giants actually rotate faster than Earth. But why does Mars have that similar? Any thoughts on that, or is there any, as far as this particular, giant impactor theory?
Well, I think it's more than just the Earth's spin. It's actually the system, the Earth and the moon together having that high angular momentum. So you've also got the moon moving quickly. Its spin is slower because it's about the same, but that's because of the kind of the captured orbit that it's in. But high angular momentum refers to the system of the Earth and the Moon together, and that's how they've determined that it's a faster angular, total angular momentum. Maybe I didn't say it as clearly as I should have at the beginning,
No,
but yeah, that's
that's okay. I was just wondering, and then I actually wrote down another question that I had, but you answered it, which was how big this giant impactor was. And I had read in the past it was, about the size of Mars is what they think. And you had stated that, so I was glad you were able to clarify that. Are there any other theories right now that people are considering as viable for the formation of the moon, or is this the one the astrophysicists and the astronomers think is really the leading theory?
Yeah, I mean, this is the one they've come to consensus to, and it was only since 1984. So, not really that long ago, and it's almost 40 years ago now. But in our history, that's such a short time. So most of the work that I've seen, as I mentioned earlier, are slight variations and alternatives to the giant. They still think it was some kind of impactor. So now there's more debate about what kind of impact, right? What was it? Was it one giant one? Was it a bunch of smaller ones? Did it happen over a period of time? With several impactors happening over a period of time? And that's kind of seems like where the research is kind of concentrated. Right now is kind of trying to, trying to spin out the details of the impactor theory.
That's pretty cool. And I know one of the things you mentioned too was that this likely created a ring around the Earth, and that would have been quite the sight to see, I imagine. Although I guess being on the surface when that happened wouldn't have been too much fun. Uh,
Yeah. Well,
but
yeah, and William, what you have to remember is the Earth wasn't anything like the Earth we know today. It had, this is occurring 4.5 billion years ago when the Earth's crust was just beginning to cool. There was no life, there was no, you know what I mean. It was still a volcanic, mess on the Earth at that time. So it was. So I've seen some literature refer to it as a proto-Earth to distinguish it from what we know as the Earth today.
I'm just wondering there was something else you said that I found very interesting, that there's uh, the volatiles were understandably not on the moon. But you said there was a lot of material on the moon that is very similar to Earth, but then there's some that's totally dissimilar.
Correct.
And it's interesting to me that if there was an impact, shouldn't some of that have been left behind?
Well, I mean, oh, you mean here on Earth?
Yeah,
That's actually an intriguing question. That's one worth looking into a little further.
every now and then I have one of those.
Yeah. I don't know the answer to that, but it could be. I mean, part of that could be. I mean, even when you think about the moon and you look at the craters and the impacts, you don't see that on the Earth, but the Earth had, almost as many impacts. I mean, many of them get burned up in the atmosphere, but because of the weather and erosion on the Earth, and plate tectonics, which we have. So a lot of that material could have been buried, over
Right.
the 4 billion years, 1.5 billion years
That
since
that seems
that
very
happened.
reasonable.
Yes.
That's I really enjoyed the presentation. I've seen you do a version of this before, and I really enjoyed it then.
Oh,
And
thank
and
you.
I learned. I mean, learning about this, but Thomas Jefferson Jackson Sea guy, and that Darwin's son
Yeah.
was involved in this as well a long time ago. It's just really cool to
Yeah.
see those connections and learn those connections.
Well, there's
Um,
actually one other tidbit in that too. Is later on, Thomas Jefferson Jackson C had written an original thesis for his undergraduate, on which he got, I don't remember the name of it, but it was an astronomy medal he got for it. But it was later found that it was mostly plagiarized from George Darwin. You know? Yes. Right.
Wow.
Yeah. Yeah. So there's even more of a connection there.
Wow.
Right?
That, that sounds like a movie.
Yeah, it does.
You
It
know,
does.
but I want to thank you for sharing this with us, and it was really great. I've seen you do some other talks on constellation lore and some other things, and I'd love to have you come back and talk about particularly the constellation lore. Um, I that's one of the things that, as long as I've been doing this, I know some of the very basics, and that's it. And I really don't focus on the lore, but a lot of people find it really interesting. So I'd love to have you come back and talk a little bit about that if you'd be up to doing that. But we
Yeah.
can talk about that another time. Is there anything else you'd like to add?
No, I think I think I'm good at this point, Wayne. Would like to say, thank you for inviting me. I enjoyed being here, and I'd be happy to come back again and talk about something else.
Awesome. I really appreciate it again, Michael, and thank you so much. And Carpe Noctem, seize the night.
Seize the
So
night. I
uh,
love that. I
thank
love that about your podcast.
thank you. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text message or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. It would be great if you would consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. And as always, Carpe Noctem, seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.